So, in the previous video, we looked at the Vigenere ciphers theory. Now, here, we're going to implement the same in code. We have the key deceptive and plain text. We are discovered, save yourself. So, we want to repeat the key. You can see that the key is shorter than the plain text. We're going to repeat it such that it has the same length as our plain text. Once the key and plain text have the same length, we can use the same indices on both, so we don't have to worry about being out of bounds for any one of them. So here we're going to capture the key length. So original key length would just be the length of the key right now. And at this point, we want to repeat the key up to plain text length. And to do that, we're going to start one letter after the last letter in the key. Remember that these things are 0 indexed. So the length of the key is 9. So at length of key, which is 9, that is an index which is directly after the last letter. So that's where we're going to start, and we're going to stop at the plain text length so that everything lines up. And we are just going to add the key to itself. And to do that, we have to wrap around. So we might as well call this M so that it matches the theory. So I mod M allows us to wrap around and take the same letters in the key to add on to the key. When we're done with this, we can print the key to see what's in the key at this point. So let's see what's in the key. I'm just going to run the script now. And now you can see that we have 3 of these. The first one was originally there, then we added 2 more, and in the end this says that the key is now the same length as the plain text. So we can now use one for loop for encryption without worrying about the indices. So we're going to perform our encryption, which is C equals to P plus K mod 26. So just remember that formula. That's exactly what we're going to use here. So we have a variable called cipher text, which is currently empty. It has no letters in it. And for I in range, the length of the plain text. And here you can use the key or the plain text, doesn't matter because they're both of the same length. And now we're going to compute each ciphertext letter as we loop through the plain text. So first, we have to make sure that the plain text letter is converted into a number, and that number is between 0 and 25. That's why we're subtracting 97. So this converts it into ASCII, then 1 is 97, converted into the range 0 to 25. Then that's our P. Then our P has to be added to our K, and for K we're going to do the same thing because K is currently in letter form at the moment, and we are going to convert that into ASCII, then subtract 97 so that it's also in the range 0 to 25. Then all of that mod 26, just like we have up here. When we're done with that, this will produce one ciphertext number, and we can take that number and convert it into a letter. And this is what you do to convert it into a letter, but remember that they're currently letters in the range 0 to 25. We have to convert those numbers back into the ASCII ranges, and we're going to add back the 97. So this is all as far as encryption is concerned, and fingers crossed this works the first time around. So we now have this, which looks like what we had in the theory section. And if you want to be more specific, we can change that to uppercase because that's how we had it in the theory section, and perhaps that looks more familiar to you. So this is how you do encryption. First, ensure that the key is repeated, or you don't necessarily have to do it at that point. You can do it in here, and you just say I mod M in there, leaving this out essentially. So that's another possibility. You can remove all of this, then just do your I mod M in there, because that was the original formula which you also covered in the theory section. So that's another way to approach this. Okay, moving on to decryption. So here we are going to do our decryption, and it's exactly the same. So decryption, and we're going to have P equals to C minus K. So that's the difference here, C minus K mod 26. So we are going to have a different variable for our plaintext just to separate it from the original one, decrypted plaintext. And we're going to loop once again, but this time we're looping through the ciphertext that we have now computed and confirmed. And we want to compute our P, and our P will be computed from, so the ciphertext is currently in letter form there. So we also have to convert it again to numbers. So that would be the current character that we're dealing with back into ASCII. Then after that, we're going to subtract 97 from it. Then we're going to subtract the key, which has to be converted into ASCII, then minus 97 again. All of this mod 26. When we're done, we expect that to produce one number, and that number will be converted into a letter using this here. And down here, we can print everything after the for loop, or when the for loop is done executing. When we run that, we have discovered save yourself, which is exactly what we started with up here. So we've done both the encryption and decryption using just these for loops. And as I said, this can be eliminated if you want. So if you have any questions, please let me know in the comment section. Like, share, subscribe. I'll see you in the next video. We'll cover yet another algorithm.